Welcome again. This is Chapter 1, Introduction to Matter and Measurement, Section 1.2, Classification of Matter. In our previous section, we saw that everything exists as either matter or energy. So, let's see how matter is classified. The two main ways in which matter is classified are according to physical state and according to composition. Let's now analyze the physical classification of matter, or as we know it, the states of matter. A sample of matter can be in either a gaseous state, a liquid state, or a solid state. These states are characterized macroscopically by their volume and shape. That is, a sample of matter in its solid state will have a definite shape and a definite volume. A sample of matter in a liquid state will have an indefinite shape but a definite volume. And a sample of matter in a gaseous state will have an indefinite shape and an indefinite volume. These states are also characterized microscopically by their particle arrangement, which in turn confers the compressibility property to the sample. That is, a sample of matter in its solid state will have its particles touching each other and tightly packed in rigid arrays. Thus, its compressibility will be negligible. What it means is that a sample of matter in a solid state cannot be compressed since there is no space among its particles. Now, a sample of matter in a liquid state will have its particles touching each other but mobile. Thus, its compressibility will be very little. And finally, a sample of matter in a gaseous state will have its particles far apart and independent of one another. And what that means is that a sample of matter in a gaseous state can be highly compressed since there is a lot of space among its particles. But teacher, what about plasma and what about the Bose-Einstein condensate states? True. These are also states of matter. Actually, there are many more states of matter proposals in the scientific community. Unfortunately, they do not form part of our course. Nevertheless, I highly recommend you do some research since I'm sure you will find very interesting information related to these states of matter. Let's now analyze the classification of matter by its composition. Matter can be classified as either pure substances and mixtures. In turn, pure substances can be either elements or compounds, and mixtures can be either homogeneous or heterogeneous. Pure substances are samples of matter that have distinct properties and composition that do not vary from sample to sample. Elements are substances that cannot be decomposed into simpler substances. That is, each element is composed of only one kind of atom. Compounds, on the other hand, are substances composed of two or more elements. That is, they contain two or more kinds of atoms. And compounds can be decomposed into simpler substances by chemical means. Now, if you remember, we said that the composition of pure substances does not vary from sample to sample. And compounds are pure substances. Therefore, the composition never changes. This statement is known as the law of constant composition or the law of definite proportions, stated by the French chemist Joseph-Louis Proust. Mixtures are combinations of two or more substances in which substances retains its chemical identity. Interestingly enough, most of the matter we deal with on a daily basis consists of mixtures rather than pure substances. One of the main differences between pure substances and mixtures is that pure substances have a fixed composition opposed to mixtures that have variable compositions. Now, homogeneous mixtures are also known as solutions, and they are uniform throughout. What that means is that the particles of the substances that form the mixture are evenly distributed along the sample, such as the example here. Heterogeneous mixtures, on the other hand, are not uniform throughout. What that means is that the particles are not evenly distributed. How so? There may be large clumps of particles on a section of the sample, while other sections have very few particles. There may be particles in the mixture which vary greatly in size from the other ones. All of these irregularities are examples from a microscopic point of view that explain how a mixture can be heterogeneous. Thank you very much.